why we need to study this particular topic. This is the point why network topology. To begin with, its answer is that with the growing use of the computer-aided solution, it is helpful to understand the methods utilized by available computer analysis tools. Means, if we want to make use of the computer-aided solution, that is generally known as CAD, is it right? Computer-aided design or maybe tools. It is helpful to understand the methods utilized by available computer analysis tool. Now, which is the method or which is the tool which can be easily understood by the computer? That is the first point of discussion. Which tool or which method is easily understood by the computer, or we can use the programming and we can find out the solution for the given thing? The answer for this question is the matrix. If we are comfortable in the matrices, then preparing of the matrices is very simple. And if we are preparing the matrices for everything using this figure or using this methodology, especially the network topology, then whatever the matrix solution is there, we can provide that matrix to the computer as an array. And in that case, if we are able to provide the matrix to the computer, then we can easily find out the solution for that. In this particular topic, we want to organize everything in the form of the matrix. If we have the matrix, in that particular case, the finding the solution for the given problem will be simple and the programming can be done. That's why throughout this topic, we will plan to organize everything in the form of the matrix. Maybe the impedance matrix, maybe the current matrix, maybe the voltage matrix, or whatever the matrices I will discuss here. As well as in this particular case, you need to understand the order of the matrix also. Order of the matrix also, that is also one point of the discussion. So here, why this network topology I have discussed, because if we want to find out the solution for any problem, or if we want to find out the current or voltage at any point, or maybe the power at any point in the given network by using the computer-aided tool, in that particular case, we will use this network topology. Means we will use the matrices, and in that case, we are able to find out its solution. That is the philosophy behind this. To begin with, what is the network topology? Network topology is the study of the geometric property of the circuit for understanding the circuit behavior. If we want to understand the circuit behavior, we will first try to study geometric properties of the circuit. This is the important keyword. Geometric properties of the circuit. Means, in this particular case, we are interested in the structure of the network rather than its elements. Because whatever the elements available in the network, those elements will come in that particular matrix directly. In place of that, initially we will try to understand the geometric property of the circuit for understanding the circuit behavior. Is it right? So here in this case, I begin the discussion with one point, that is the graph of the network. Graph of the network. What is a graph? And we will try to understand how are the graph and so many things. A graph is a set of the nodes, generally known as vertices. A graph is the set of the nodes, that is vertices, together with the set of the branches, that is nothing but the edges, with the condition that each branch terminates at the node and all sources are replaced by the respective internal resistances. That is, the voltage source is replaced by zero resistance and current source is replaced by the infinite resistance. This keyword, or this we need to understand. While drawing the graph, while drawing its geometric behavior, geometric property, the set of the nodes, generally known as the vertices, together with the set of the branches, generally which is known as the edges, with the condition that each branch terminates at the node How is this? That I will discuss here. Now this is the given figure. Try to understand for this given figure how many branches we have. That is nothing but what are the branches? Try to understand this philosophy. Branches is nothing but the edges, and nodes are nothing but the vertices. Now first we will try to understand how many nodes we have and how many branches we have. This how many vertices we have and how many edges we have. Now this is one node, this is the second node, this is the third node, and it is the fourth node. Right? Then look at how many branches we have. This may be the one branch, second branch, third branch, fourth branch, fifth branch, and this is the sixth branch. But our figure may not consist of the same number of the branches, because what we have, the source is, this is current source, this is current source, and this is voltage source. Current source will be replaced by the infinite resistance, means nothing will be connected between these two nodes. Nothing will be connected between these two nodes, because as far as this branch is concerned, because it should be replaced by the infinite. Is it right? And again, this branch is also replaced by its infinite resistance. But suppose I want to draw the graph for this particular circuit, how will be the graph? I will show the graph later on. But before that, this is one node, this is another node, and this is the third node. First we will draw the nodes, and this will be the last node. In this graph, what we have to do, drawing the graph is a simple thing. Just this is the approach which we can use at the basic level. That is maybe at the first standard or second standard. That kind of the approach is there. Is it right? Now look at this branch is replaced by this part. This is branch in the graph. This may be the second, which is this. This may be the third, which is this. And this voltage source will be replaced by its internal resistance. Internal resistance of the voltage source is 0. That's why between this A and the C node, we have only one branch, something like this, which is something like this. Is it right? And after that, there is no element in the circuit, because here is one node we have, here is one node we have, here is another node we have, this is the third node we have, and this is the fourth node we have. Is it right? Now what we have done, this branch we have replaced by this part, this branch is replaced by this part, and finally the last branch is replaced by this part, and here this branch is replaced by this part. No need to use this, or no need to show this part and this part in the figure, because between this A and D nodes, suppose I am giving some names to the nodes. Suppose I am giving some names to the nodes. Suppose this is the A node. This may be the B node. This is the B node. This is the C node, suppose. And this may be the D node. This is right. This may be the D node. In that case, between this A and D, suppose I will take it as a D node. Between this A and D, as far as this path is concerned, there is only current source. That's why current source will be replaced by the infinite resistors, as well as this current source is also replaced by the infinite resistors. This is the complete graph of the network. Is it right? This is the complete graph of the network. I will come back to you. I will discuss 3 points with you. Yeah. So here in this case, this is the graph for that case. Is it right? This is the graph. Here it is A node, maybe this is B node, this may be the C node, and this may be the D node here. In this particular case, we can give the names to the branches also. This is the branch number 1, this is branch number 2, branch number 3, and branch number 4. This is the example of the graph. Believe me, this is very, very simple, but we need to understand its concept very clearly and very carefully. I will come back to you. I will unmute to all of you one by one, and then I will discuss. Yeah. Akash.
Yes, sir.
Any difficulty in the understanding how to draw the graph?
No, sir.
No. Then I will come back to you again, Chaya.
Yes, sir.
any difficulty in the understanding of this? How to draw the graph for the given figure?
No.
No doubt. Okay, fine. I will proceed further again. So here, if this is the given circuit, for this particular circuit, we can draw the graph in this particular way. Is it right? Now, I will go to the next example. This is another example. Try to understand the nodes and branches concept. And after understanding that, we can draw its graph. Now for this figure, how will be the graph? I will show its solution later on. But before going to the solution, we need to understand how will be this particular figure. In this case, this is one node. I will call it as A node. This may be the B node, and this may be the common node, which is the C node. A, B, C. How many branches we have? This is one branch, second branch, third branch, fourth branch, and this is the fifth branch. In that case, if I am trying to draw the graph, in that particular case, graph will be something like this. Is it right? I will give some names here. This is branch number 1. This is the branch number maybe 2. This may be the branch number 3. This may be the branch number 4. Or this may be the branch number 5. Is it right? Branch 1, 2, 3, 4, and 5. Is it right? In this particular case, how will be its graph? I'm that trying to show that. This is one branch, which is the branch number 3. This is another branch, which is the branch number 4. This branch. Again here, this is the another branch, which is the branch number 5. This is the branch number 2. And here, this is the branch number 1. This is the branch number 1. This is the graph for this case. Is it right? But in some books, you will find little different terminology. You can use any one, but I guess this is the simple. Suppose in this case, if we have one resistance here, something like this. Is it right? In that case, the figure will be the same, but branch resistance will be this 2 ohm and maybe another this is 2 ohm. We can add these two values and we can put up in the impedance matrix. Whenever I will go to the impedance matrix, I will discuss. But in some books, you will find out the terminology. This is one node here. This is the second node, which is here. And this is the third node, which is here. Actually, this is not the node. But to separate the elements, generally they are drawing that kind of the approach. This here, in that case, this will be the branch number 3. This may be the branch number 5 or this part. Is it right? In that way. And they are drawing the figures. Is it right? Then this branch and finally figure will be coming as the same. In that case, this will be the one terminology. This here, in this case, this may be the one part. Is it right? Which is this branch number 2. This is the branch number I will draw here. This is the branch number 3. This is the branch number 2. And this is, I will name it as a 5 and I will mark it as a 6 now because I have separated the two parts. This is part, this part and this part. Then this will be the branch number 5. This may be the branch number 6 or element number 6 to be exact, not the branch. Element number 6. Then I can draw here the element number which is the 4 and finally I can draw this is the element number 1. This terminology may be used in some of the books, but what I will treat, I will never use this terminology. ऐसा terminology मैं use नहीं करूँगा. I will treat this complete as a single branch and I will draw something like this. Because whenever you are referring to the maybe some standard books or maybe some local books in that particular case, you will get confused about this terminology. But generally this is the standard terminology used in the standard books. This may be the another approach, but I will use this as a complete single branch, which will be something like this. This is the graph. Look at here, how is the graph in this particular case? Now here in this case, this is one node, this is the second node, this is the third node. This node is A node, this is C node, and this is the B node. This is one branch, its central resistance will be 0, that's why it will be one branch. This is branch number 1, this is the branch number 2 here, This is the branch number, this is the branch number 5, this is the branch number 3, and this complete. This complete is the branch number 4. And this is the graph for given network. Miss here, as far as the given figure is concerned, you must be in a position to draw the graph for that given figure. That is the terminology. Then I will discuss about the new definitions, but before that, I will come back to you and I will discuss, are you sure about whether you are in a position to draw the graph for given network? I will come back to you. Yes, Akash?
Yes, sir.
Are you sure about you are in a position to draw the graph for the given network?
Yes, sir.
Yes. Chinmay?
Yes, sir.
Are you in a position to draw the graph for the given network?
No, sir. I joined late, sir.
That is the difficulty. And again, you are looking at some other websites.
No, sir. वो update आया था, change किया.
Okay. Then I will come back to Chaya. Are you able to draw the graph for the given network?
Yes, sir.
Yes. Then Rishikesh.
Yes, sir.
Are you in a position to draw the graph for the given network?
Yes, sir. Yes.
Okay, fine. Then Ruchira.
Yes, sir.
Are you in a position to draw the graph for the given network?
Yes, sir.
Okay, fine. I will minimize the screen and I will come back to my camera and I will discuss about how to draw the graph for the given network. This is the figure. Are you able to see my paper? Yes. So here in this particular case, we will try to understand how to draw the graph for this given figure. That is my philosophy. Now look at how many nodes we have for this particular figure. I am expecting the answers from your side.
किती नोड आहेत? मी आता आलो.
Yes, who is that? Mute yourself. Saurabh. Yeah. Now here in this particular case, how many nodes we have for this particular figure? Now look at, I will mark the nodes. This is one node, maybe node A. This is the second node, maybe the node B. This is the third node, which may be the node C. Is it right? And this may be the common node, which is the ground node. I will call it as a node D. Try to understand the philosophy. Here, the values of these elements are not important right now. The values are required. But when we will go to the calculation of the tie-set matrix or cut-set matrix or the calculation of the current in the branches, in that case, we need those things. But right now, it is not required. That's why I have not drawn. In this figure, we have 1, 2, 3, and 4 nodes. Now, how will be the graph for this given network? First, I will draw the 4 nodes. This is one node, this is the second node, this is the third node, and this is the fourth node. This node, I will name it as node A. This node, I will name it as node B. This node, I will name it as node C. And this node, I will name it as node D. At the same time, I will give the numbers to the branches. This is the branch number 1. Generally, the current source is replaced by the open circuit because its internal resistance is infinite. That's why we will not name it as a branch, because it will be replaced by its internal resistance, which is infinite. That's why this is the branch number 2, this is the branch number 4, this is the branch number 5, and this is the voltage source. It will be replaced by its internal resistance. Is it right? This is the branch number 6, this is the branch number 7, and finally it is the branch number 8. Is it right? And I am not giving any name to this current source branch, otherwise we can give it, but we will not consider this branch in the graph. That is the philosophy. Is it right? Now look at it. First, I will draw the branch number 1. This is the branch number 1 in the graph. How is the branch number 1? It is replaced by one path. That branch is replaced by one path. This is one path. I will draw the branch number 2 between the nodes A and B. This is branch number 2. I will draw the branch number 3. This is the branch number 3. Is it right? Then I guess I have not drawn the branch number 4. I have not given the name for the branch number 4. Okay, fine. Whatever the names I have given, I will proceed with that. This may be the branch number 5. This is the branch number 1 I will draw. This is the branch number 2. This is the branch number 3. This is the branch number 5 because the names are not important. This is the branch number 6. This is the branch number 6. And this is the branch number 7. This is the branch number 7. And finally between A and C we have another branch, and this branch is nothing but the branch number 8. And be careful, I am not considering this branch number 9 because branch number 9 is the current source. Agar iski jagah aur kuch hota resistance, then I would have been drawn here, somewhere here. Is it right? This is the given network and this is the graph for that particular network, and this is the terminology to draw the graph. Because we have so many definitions in this particular chapter. That's why I want to clarify each and every definition at that point itself. Is it right? If anyone has any difficulty regarding drawing of this graph for the given network, because heading itself indicates draw the graph for the network shown below. For this network we are trying to show the graph or trying to draw the graph. This is the graph for this given network. If anyone has any difficulty related to this, please raise your hand, otherwise I'll proceed further. Is it right? Now this is the concept of the graph and how to draw the graph. Is it right? Anyone has any difficulty related to this? Yes. No difficulties. Okay, fine. I will proceed further. Now here in this case, I will go to the definition of the another definitions of this graph. Here one definition is the planar graph. What is the planar graph? A graph drawn on two-dimensional plane such that no two branches can intersect with each other is known as a planar graph. Means here there should not be the overlapping of any two branches. Is it right? But as far as this figure is concerned, you will get confused about this is also planar graph. Because here in this case this is node, this is node, this is node, this is node. Here there is no overlapping of the branches in this case as well as in this case, but here is overlapping of the branches in this particular case. But look at how this graph can be drawn. This graph can be drawn something like this. This graph can be drawn something like this. This is the branch number 1. This may be the branch number 4. This may be the branch number 2. And the branch number 3 between this node and this node. Between this node and this node, not necessarily we should draw something like this. We can avoid it, or I can draw that particular branch in this way. Now, this is one node. This we have the 4 nodes. This is 1, 2, 3, 4. This is again we have. This is one node. This is one node we have. This is the second node we have. This is the third node we have, and this is the 4th node we have. And no branches are overlapping now. Because we can modify this graph, but in some cases we are not, even after modification, if we have the overlapping of the branches between any two nodes. Yes, sir? So here in this particular case, there should not be the overlapping of the branches. And that graph is nothing but the planar graph. If there is the overlapping and we cannot avoid it, in that case that is the non-planar graph. Otherwise it is planar graph. I will show the examples of the non-planar graphs also. This is the planar graph. Is it right? I will show the examples. Now look at here. In this particular graph, use any combination. At least one branch will be overlapped with each other. And such graph is nothing but the non-planar graph. We cannot avoid it. अगर हमने इसको बाहर लिया, इस branch को अगर if we are drawing this branch something like this, and if we are drawing this branch something like this, again there may be the overlapping of the other branches. इसको कैसे draw करेंगे? Internal है, and so many things are there. That's why a graph drawn on the two-dimensional plane such that branches can intersect with each other is known as a non-planar graph. We cannot avoid it. At least one branch will be there which is overlapping. Such graph is nothing but the non-planar graph. Is it right? That is the non-planar graph. And here in this case, even though here is overlapping exists here, then also this graph or this line or maybe this line can be drawn in the different way. Maybe something like this, excluding that part. Without touching to that particular node, we can draw that particular line, something like this. This line number 2 can be drawn something like this. That is nothing but this graph can be converted into the planar graph. Even though it is looking to be non-planar graph, but this graph is the planar graph. Again, I will come back to you because definitions are little clumsy. That's why I will come back to you again. Akash, have you understood the difference between the planar graph and non-planar graph?
Yes.
Okay, fine. Yeah. Then Saurabh.
Yes, sir.
Yeah. Then Tanveer. Tanveer, are you there? You must be in a position to differentiate between planar graphs and non-planar graphs. I am clearing every doubt at each instant of the time because we have a lot. Then I will come back to slides and I will discuss the next part. Here we are trying to understand the new philosophy or new terminology, that is directed graph or oriented graph. I will read out its definition because so many definitions are there. You should not confuse with any definition. A graph whose branches are, it is a graph whose branches has a particular direction of the current, and it is known as a directed graph or oriented graph. Means it is a graph in which if we are showing the direction of the current on that branches, those graphs with the direction of the currents in the branches is shown is known as a directed graph or oriented graph. This is the example of the directed graph or oriented graph. Similarly, I will discuss about this next point later. Before that, I will come back to the slides which I am discussing with you, this part, and we will discuss how is the directed graph or oriented graph. Suppose this is the given figure, and in this particular figure we can assume any random direction. Again, there is no restriction to assume the directions of the currents. You can assume any direction. Suppose I have taken this direction upward, this may be the downward, this may be the forward, this may be the downward, this may be the forward, this may be the downward, this is downward, again this is the forward. Select one suitable direction of the current for each branch. जैसे हम नोडल एनालिसिस में करते हैं. In the similar way, we will assume any direction randomly. Is it right? And there is no need of showing the direction for this current source branch because anyhow we are not considering this branch in the graph. इस graph में हम consider नहीं करेंगे. That's why you can show it or you can leave it. That is your choice. Now look at how is the direction of the branch number 1. It is downward. That's why its direction is downward. Branch number 2, it is a forward. Branch number 3, it is downward. Branch number 4, I have not shown. Branch number 5, it is a forward. Branch number 6, which is downward. This branch number 7, it is downward. This branch number 8 is downward. Now, the same graph is known as the oriented graph or directed graph. Previously, it was just a graph. Now, if we are assuming the suitable directions in the figure, and if we are replicating the same directions in the graph, in that particular case, this graph is known as the oriented graph or directed graph. Is it right? Is it clear? If anyone has any difficulty, just raise your hand. It is the methodology of this oriented graph or directed graph is the same as the terminology generally which we will use in case of the nodal analysis method. In case of the nodal analysis method, we will assume the separate current for the separate branch and the same direction we are showing in the graph, and that graph will be named as the oriented graph or directed graph. That is about the definition of this graph, oriented graph or directed graph. In the examination also, they can mention define graph and oriented graph. You should be in a position to define the graph. How is the graph? How is the definition of the graph? This is the definition of the graph. What is the graph? It is a set of the nodes together with the set of the branches with condition that each branch terminates at the node and all sources are replaced by the interrelations. That is the definition of the graph. How is the definition of this planar graph or non-planar graph and this directed graph? As far as this directed graph is concerned, graph whose branches has a particular direction is known as a directed graph or oriented graph. In the examination also, many times they ask the definitions related to these simple points, as well as there is complex solutions are also available. I will discuss about the complex solutions later on, one by one. This first I am trying to introduce you this topic. Its terminology. Is it right? Then here in this case, this is the connected graph. How is the definition of this connected graph? Try to understand. The graph in which all the nodes are connected to each other directly or indirectly, at least by one branch, is known as a connected graph. So here in this particular case, this is the node 1, this is the node 2, this may be the node 3, this may be the node 5, this may be the node 6. Node 5. And all these nodes are connected to each other directly or indirectly. For example, this node 4 and node 3 is connected through this branch number E and branch number 6 indirectly. This branch, node number 5 and node number 3 are connected directly through this branch number G. Is it right? Such a graph is known as a connected graph. In this case, this is also connected graph. This is first point, this is second point, this is third point. That is node A, B, C, and D and E. This is the node A, node B, node C, node D, and node E, maybe. In this case, all the nodes are connected to each other directly or indirectly. In this case also, this is one node, this is second node, this is the third node, this is the fourth node. In this case also, all the nodes are connected to each other directly or indirectly. And that's why all these figures are the figures of the connected graph. All these figures are the figures of the connected graph. Is it right? Now I will discuss this next definition. Next definition, that is unconnected graph. I have not shown that, but I will discuss that. How is the unconnected graph? Now look at carefully. If we have the figure something like this, there is one coil, here is the resistance, something like this, and here is the source. Maybe the AC or DC, something like this. And in this case, we have, here is another coil, that is transformer. And in this case, we have the element something like this. This is right. If we are drawing the graph, we have to separate this as a node because it is a transformer. Is it right? We have to use the different terminology. This is one point, this is second point, this is third point, and this is fourth point. How will be the graph? This is one node, second node, this may be the third node, this may be the fourth node. One connection will be something like this, another connection will be something like this. Here is one connection and here is another connection. But between this part of the network and this part of the network, there is no connection. Such graph is known as the unconnected graph. This is connected graph, or it may be the unconnected graph, maybe something like that.